Hello and welcome to another of my chemistry videos. Today we'll be covering material under Nevada State Science Content Standard P12A7. It says that students know that in chemical reactions, elements combine in predictable ratios and the numbers of atoms of each element do not change. And the objective is that upon completion of this lesson, students will be able to correctly balance a chemical equation. So balancing equations. Whether they're word or formula equations, you're probably going to start with a word problem. Your second step is to change the word names for chemical formulas. As we all know, sometimes word problems can contain a lot of fluff that you don't really need. So if you can pick out the information you need, in other words, the chemical formulas, you're on your way to success. Once you have them all picked out and in their proper locations under reactants or products, you're going to need to balance the equation. This means there must be the same number of atoms of each element, or all the elements, on both sides of the equation. There is a trial and error method that makes things easier, and you can follow these guidelines. Balance different types of atoms one at a time. First, balance atoms that are combined and appear only once on each side of the equation. Next, balance polyatomic ions that appear on both sides of the equation as single units. Don't try, if you have a sulfate, don't try and balance the sulfur and the oxygen separately. It's often easier to balance two sulfates with two sulfates, for example. And finally, balancing hydrogen atoms and oxygen atoms after atoms of all other elements have been balanced can make it easier because often hydrogen and oxygen can show up all by themselves. Before we begin, some other background on these. Common symbols used in chemical equations. You might see an L in parentheses. That would stand for a liquid. G, as we can see down here, stands for a gas. AQ would stand for aqueous, in other words, something dissolved in usually water. Most acids fall under this category. And S for a solid. The coefficient of chemical reactions indicate relative, not absolute amounts of reactants and products. In other words, if I have this chemical equation right here, and if I were to say this, it would say that 1 molecule of methane and 2 molecules of oxygen react. That tells me these are my reactants to produce. Now there's a key phrase that usually means you write your arrow in. Arrow always points at your products. They react to produce 1 molecule of carbon dioxide and 2 molecules of water. These coefficients in the front tell you how many molecules they are. You could also look at it as that's how many moles there are, in this case 2 moles of water. If there's no coefficient in front, it's assumed that there is 1 molecule or 1 mole, in this case carbon dioxide. This could, and when we say that they're relative amounts, this could just as easily be 100 molecules of methane, 200 molecules of oxygen, producing 100 carbon dioxide molecules and 200 water molecules. In an earlier video, we discussed empirical and molecular formulas. Well, this leads into empirical and molecular equations. We may get into this in a future video, but for now that's enough to know. Okay. Secondly, masses of the reactants and products can be determined by converting moles to grams, which by this time you should already know how to do. The reverse reaction for a chemical equation, some chemical reactions are reversible, they'll have the same relative amounts of substances as the forward reaction. In this video, we're not going to do anything with that, but again, it's not possible to know too much. Now here's an example, and we can talk through this. It may make more sense than the last slide. Here's our word problem. Not a lot of fluff in this one, but when methane and oxygen burn, they react to produce carbon dioxide and water. Now if this were a real fluffy word problem telling you the direction of the wind and the phase of the moon, it might be easier to pull out, okay, methane. I know that methane is one of my reactants. So I'm going to write methane here. I need that. And oxygen, okay, there's a chemical that I need right here. Okay, it says they burn to react. That tells you that these are your reactants. To produce, there's that key phrase again, where you write your arrow in, and you're transitioning to products. It produces carbon dioxide and water. There's your word names. Next, and in this particular word problem, like I said, there's not a lot of fluff, so if you find it easier, feel free to skip this word name step and launch right into changing methane to its chemical formula of CH4, oxygen to O2, carbon dioxide to CO2, and water, as you know, to H2O. And then your final step would be to balance this thing. Now, this one is already shown balance, but if it wasn't there, this is pretty much my method of balancing them. There's more than one way to do it. I'm just going to show you how I would do these. First, I draw a line between the reactants and the products. And on each side, I'm going to list the elements that appear in the formula. Okay, I have carbon, I have hydrogen, whoops, I have oxygen. And I'm going to list the same thing on the other side. I also have carbon, I have hydrogen, and again, oxygen. And I'm going to list how many elements of each, how many atoms of each element I have on each side. Okay, so starting up here with carbon, I look up here in my unbalanced formula, and it only shows one carbon atom, so I'm going to put 1. It shows that I have 4 hydrogen atoms, so I'll put 4. And I have 2 oxygen atoms, so I'm going to put 2. And on the product side, up here I have 1 carbon again. I have for hydrogen, there's 2, so I'm going to put a 2. Oxygen, okay, I've got 2 of them over here in the CO2, and I've got 1 here in the water, so that's a total of 3. Okay, before I start balancing this, these smaller numbers that are down a little low, they're called subscripts. You cannot change those. Do not increase their number. Do not decrease their number. These are taboo. They stay just the way they are. To balance these, to change the number of carbons or hydrogens or oxygens on either side, what you can do is change what's called a subscript, and it's a number that goes in front of a molecule. Okay, now subscripts you can't split a molecule apart and put a 2 in here, for example, if I wanted one. It's got to go in front of a molecule. Okay, so let's look at this. I have 1 carbon on this side, 1 carbon on my products. I have 4 hydrogen for the reactants, but I only have 2 for the products. So that means on this side of the equation, I need more hydrogens. So in order to do that, what I did was I put a coefficient of a 2 right here, and so that means now I have 2 water molecules under my products. So if I multiply this through, I have two molecules here. 2 times 2 hydrogens changes it to, now I have 4 hydrogens for my products, but it also changes the number of oxygens. I now have 2 oxygens because there's 2 H2O molecules, so there's 2 there, and I also have 2 over here with the CO2. So that changes my number of oxygens to 4. Okay, looking good so far. So my carbons are balanced, my hydrogens are balanced. Now I just need to look at these oxygens. It looks like I need more on this side. So what I did was I put a 2 right here in front of this O2. So 2 molecules times 2 oxygens in each molecule gives me a 4. And now it's a balanced equation. We've got 1 on this, 1 carbon, 4 hydrogens, 4 hydrogens, 4 oxygens, 4 oxygens. Life is good, and we're moving on to the next problem. Now this next problem is a word problem. And just as above here, where we could pull out the information we need, This one doesn't have a lot of fluff, just like the last one. So I think I'm just going to jump straight to the formula step and just pull out the formulas. Let's try a different. Okay, so we've got solid zinc, Zn, the elemental symbol for zinc, reacts with, okay, so that means we've got another reactant, so let's put a plus in here, aqueous copper 1 sulfate. Okay, aqueous means, again, that is dissolved in water, but we don't really need to worry about that at this point. Let's put copper, Cu. Okay, it says it's copper 1, which means it has a charge of +1. And a sulfate is SO4, which has a charge of 2 negative. Okay, so our charges aren't balanced. That means we're going to need 2 coppers over here to balance with the 1 sulfate over there. So I can put a 2 right there, and then erase these charges. I don't need those anymore. All right, good there. Okay. To produce, so I got zinc metal with copper sulfate reacting to produce. There's our key term. We got an arrow pointing at our products. Produces copper metal, solid copper metal. So we've got a Cu for copper. And, okay, so I got another one. And zinc sulfate. Okay, zinc always has a charge of 2 plus. And a sulfate having a charge of 2 minus means I only need 1 of each of those. So I can just do this and I'm set. Okay, now we need to balance this thing. Okay, we need a little more room here. So first I'm going to draw a line to separate my reactants and my products, and on each side I'm going to list all the elements. So I've got zinc, I've got copper, and we can either list the sulfur and oxygen separately, or we can just look at that and realize, hey, that's a polyatomic ion. I think I'm just going to list them separately this time. So sulfur and oxygen. So on this side I have 1 zinc, I have 2 copper, I have 1 sulfur, and I have 4 oxygens. Over to the other side, list them in the same order, makes it easier. We got zinc, we've got copper, we've got sulfur, and oxygen. So for zinc, we have 1 zinc, copper, we have 1 copper, sulfur, 1 oxygen, 4. So it looks like the only thing we need to balance is these coppers. We have 2 here and only 1 on this side. This is an easy one. Let's just put a 2 right here in front of this copper for a coefficient, changing that number to 2, and we're balanced. Life's good. Moving on. Okay, at this point it's probably a good time, before we get into word problems, to look at the 7 diatomic elements. These are elements that as you're reading through a word problem, you'll come across it. It'll say something reacts with hydrogen, and when you go to write your formula, you'll be tempted to put in just an H if you don't know any better. Hydrogen, when it's all by itself, is going to always be H2. And there are 7 elements that do this. Nitrogen will never be just N, it'll be N2. Oxygen, usually an O2, fluorine, F2, and so on. Chlorine, Cl2, you get the idea. Okay, here's a chance where you get to try it, one of these word problems. And if you want to try it on your own, feel free to pause the video and do so. Otherwise, I'm just going to launch right into this. Okay, hydrogen peroxide, H2, 2 O2. And an aqueous solution decomposes, so we have a decomposition formula here. To produce, here's our arrow, oxygen. Okay, now oxygen, remember, was one of the diatomic, one of the 7 diatomic. You got to have an O2 there. You can't just leave it an O. So O2 and water. H2O. And then we draw our line to balance this. Hydrogen, oxygen, and only hydrogen, oxygen on this side. Hydrogen, oxygen. So we've got 2 of each on this side. We've got 2 hydrogen over here, and we have 3 oxygen on this side. Okay, so our oxygens aren't balanced. We need more of them over here. Now sometimes when you do this, increasing the number of oxygens is obviously going to increase the number of hydrogens. That's okay. In the end, it's eventually going to work out. You may have to go back and forth from one side to the other, balancing several times to get this to work. But just take it slow. These can be time consuming, but in the end, you'll get it. Okay, so we need more oxygens over here. We have 1, so our next highest coefficient, let's try a 2. Okay, we've got a 2 here, so that means we've now got 4 hydrogens and 4 oxygens, meaning we need more hydrogens on this side, so let's put a 2 right here. Now we have 4 hydrogens, and let's see, we've got 2 oxygens here in the water, 2 molecules plus the O2, changes that to a 4, and we're balanced. Okay, pretty easy, huh? Okay, let's try one more. Solid copper metal reacts with, so we've got Cu, copper, reacts with, so plus, aqueous silver nitrate. Silver is Ag. Silver has a charge of +1. Nitrate, NO3, has a charge of -1, so we only need 1 of each of these to produce. So now we're going to the other side of the equation. Silver metal, so just silver all by itself, Ag, and an aqueous copper 2 nitrate. So Cu, I'm going to put the charge in there because they tell us it's 2. I'm going to put the 2 up there, so 2 plus, and as I mentioned just a little bit ago, the nitrate, NO3, has a charge of -1. So this means that for every 1 of these, I'm going to need 2 nitrates. So I'm going to put this polyatomic ion in parentheses and put a 2 right there. And I can get rid of my charges. Okay, clean that up a little bit. All right, let's balance this thing. So we draw our line. I need a little more room. Okay, on this side we have copper, listing our elements. We have silver. We have nitrogen. And we have oxygen. 1 copper, 1 silver, 1 nitrogen, 3 oxygens. Going over to this side, okay, copper. Again, I try and keep them in the same order. It makes it easier to keep track of. Copper, silver, nitrogen, and oxygen. So copper, we have 1 of those, silver 1, nitrogen. Okay, we've got 2 of these. ions, so that means 2 nitrogens. And since there are 2 of these, that means 6 oxygens. Okay, so 1 nitrogen, 2 nitrogens. Let's start with the nitrogen. Okay, start with a 2 right in front of here. That should balance the nitrogens. Okay, first off we have 2 silvers, 2 nitrogens, and 6 oxygens. Okay, change these other ones, but that actually helped us a little bit, didn't it? Okay, so let's go back to this side because now it appears we need more silver on this side. Simply put a 2 right here, and we're balanced. Okay, I think that's going to be it for this video. We'll cover a little bit more in our next video. We'll do a little bit more on balancing with equations, and maybe we'll spend a little bit more time on going from word problems into the equations. Thanks for watching.